Alright, 8th graders, we're going to be completing 4.1 and 4.2 today to find the hypotenuse, and you have a 1 by 1 triangle, and if you have a 1 by 1 to find the hypotenuse, you would do 1 squared plus 1 squared to equal c squared. That would be 1 plus 1, which is 2, so c would equal the square root of 2. I'm actually going to write this 2 equals c squared, square root both sides. So this right here is c, this hypotenuse, so you would put square root of 2 on your paper. Now, square root of 2 is 1.414. It is already put right here for you, and your ruler is at the bottom of your paper. Okay, so our next triangle is a square root of 2 by 1. So square root of 2 squared plus 1 squared will equal c squared. So now our goal is to find this hypotenuse. I could even make that color. So the square root of 2 squared is 2, 1 squared is 1, so c squared is going to give you 3, so the final answer would be the square root of 3. And the square root of 3 in your calculator, if you don't know, you can get your calculator out. I think it's 1.7 something. .732. So if you come down to the bottom, 1.123456732. That's square root of 3. All right, next up, we have the square root of 3 by 1. So the square root of 3 squared plus 1 squared will equal c squared. This time we're looking for this hypotenuse. So the square root of 3 squared is 3, 1 squared is 1, therefore c squared is going to be equal to 4. The square root of 4 is the whole number of 2, so that is the number 2. So under 2, you can put square root of 4 because that is 2. And then you have the square root of 4 and 1 giving you this hypotenuse. So the square root of 4 squared plus 1 squared will be 4 plus 1. So that hypotenuse would be equal to the square root of 5. So in your calculator, you're going to see what square root of 5 is. It's 2 point something. .236. So 2.236. All right, are you noticing a pattern yet? So this would be square root of 5 by 1. So square root of 5 squared plus 1 squared, that's a 5, man, will equal c squared. That means that 5 plus 1 will equal c squared. So c squared will equal 6. So c is the square root of 6. So this would be the square root of 6. Square root of 2, square root of 3, square root of 4, square root of 5, square root of 6. Every time you've got 1 as your leg. So this whole pattern just continues. Square root of 9 is 3. So it's kind of cool. So we're going to put those on our tape measure ruler thing. Okay, so square root of 6 is 2.449. So 2, 1, 2, 3, 4 right here. And then we'll do square root of 7. Whoops. 2.645. And then square root of 8. $2.828. And then square root of 9 is 3. So you're noticing that from 0 to 1, there's really not a lot of square roots. So from 1 to 2 are the numbers 2 and 3, because 1 squared is 4 and is 1, whoa, and 2 squared is 4. So all of the numbers between 1 and 4, which is 2 and 3, will lie between 1 and 2 on the number line. So then since 2 squared is 4 and since 3 squared is 9, that means that 5, 6, 7, 8 will all lie in between the numbers 2 and 3. So now 4 squared is 16. So in between these two is going to be 10, 11, 12, 13, 14, and 15. So it's kind of like as we're going up, there's more and more square roots in there. So we still need to graph 10, 11, and 12. So 10 is 3.16. Eleven is 3.316, so 3.317. Twelve is 3.464. So you can see how really they are getting closer and closer to each other. So if you flip that over, let's see here, flip it over, you have none of these questions. And I don't have the baseball diamond. Okay, so I'm just gonna draw it. So in 4.2, you have this lovely baseball diamond. And each side is 90 feet. And these are all supposed to be perfect 90-degree angles. And the pitcher's mound is right here. And letter A says, how far must the catcher throw the ball to second base? So, and it says the catcher is standing on home plate and the second base person is standing right on home plate. Isn't that convenient? So, you are looking at a right triangle right here. So it looks just like this. This is 90, this is 90, this is home, this is second. So to find that diagonal length, you would just do the Pythagorean theorem. 90 squared plus 90 squared would equal c squared. So this is our c right now. So 9 times 9 is 81. So this is 8100 plus 8100 equaling c squared. So that's 16,200 equaling c squared. And so if you want to know the exact length for c, you would need to square root 16,200. And we know that our number has to be more than 90, and it is 127.279. and that is in feet. So you should add your units. So that is A. B says the shortstop is standing halfway between second and third base. So I'm just going to draw another picture. You can just use the same picture at the top. Oh boy. Okay. So this is home. These are all 90. And it says the shortstop is halfway between second and third. So if this is second, this is third, the shortstop would be right here. This would be 45, and this would be 45 because it's halfway in between. How far is the throw from home to shortstop? So you're looking at this lovely right triangle. So it's a 45 by 90, and here's the throw from home to shortstop. So you would do 45 squared plus 90 squared, giving you C squared. 45 times 45 is 2025. 2025. Okay, so 2025 plus 8100, and I actually already did that in the calculator, which is 10125. And then you would need to square root both of those. And remember that special little thing in the calculator? You can go to second answer, second negative, and it gives you the last answer. So that is 100.62. So 100.62 feet. And it does make sense that that's a little bit smaller because the height's smaller. And then the last one, C, says the pitcher's mound is 60 feet 6 inches from home plate. Find the distance from the pitcher's mound to each base. Okay, so I'm going to go back up to this. And I think the bell's going to ring on me, so I might have to finish this in class tomorrow. But this is 60 feet 6 inches. So 6 inches is half a foot. So the pitcher's mound, this is 60.5 feet. So you would need to take the 127.27 and subtract the 60.5. So this distance to second base would be 66.77 feet. So then, since you know this is 90, and you have to find how far from the pitcher to third, which is going to be the same as from the pitcher to first. This time you're given the hypotenuse. This is the biggest, so we'll call this A. It doesn't matter if you call it A or B. So A squared plus 66.77 squared would have to equal 90 squared. So to solve for A squared, you'd actually subtract this. So it's 90 squared minus 66.77 squared, and then take the square root. So 8100 minus 4458.232 So we're going to do 8100 minus that number, which is 3641.767. And then you're going to take the square root of both sides. So then A would equal 60.347. So that would be the distance here as well as the distance here. So that's letter C on your paper. So just to make sure you understand, if you are given the hypotenuse, since you know a squared plus b squared equals c squared, it is also true that c squared minus b squared equals a squared, and that c squared minus a squared equals b squared. So again, if given the hypotenuse, you would need to subtract the square numbers to get the final answer for the side length. And the side length, the two legs, should always be less than the hypotenuse. So the legs, these are the legs, the A and the B. These are like this matches up with this angle, this matches up with this angle. These legs are always smaller than the hypotenuse because the hypotenuse is across from the biggest angle. The three angles of a triangle add to give you 180. So if this is 90 degrees, it's a right triangle, biggest side length. The other two together are 90 degrees. This plus this is 90 degrees. So they're always smaller than the right angle side. All right. Hope that was invigorating for you. Have a lovely evening.